Very good morning to all.
Good morning, sir.
Good morning, one
Good
and
morning
all.
to all.
A warm welcome to this webinar. Each day invites us to feel the fragrance of God's love. Let's begin this day with prayer. Prayer has immeasurable power. Prayer brings wisdom and victory. Prayer builds up our inner strength. Prayer brings sweetness and delight. Yes, to invoke God's presence among us, I welcome you all to join in this prayer song.
God will make a way where there seems to be no way. He works in ways we cannot see. He will make a way for me. He will be my God. Hold me closely to His side. With love and strength for each new day, He will make a way. He will make a way. Oh, God will make a way where there seems to be no way. He works in ways we cannot see. He will make a way. He will be my God. Hold me closely to His side. With love and strength for each new day, He will make a way. He will make a way. By the roadway in the wilderness, He will lead me. And rivers in the desert will I see. Heaven and earth will fade, but His word will still remain. And He will do something new today. Oh, God will make a way where there seems to be no way. He works in ways we cannot see. He will make a way for me. He will be my God. Hold me closely to His side. With love and strength for each new day, He will make a way. He will make a way. Love and strength for each new day, He will make a way. He will make a way.
Mountains welcome winter, flowers welcome spring, fruits welcome autumn. Likewise, we would like to welcome the dignitaries and all the participants to this webinar. Yes, now comes the welcome address by Mrs. Jamuna Rani, H.D. Department of Computer Science. I welcome you, ma'am.
Mic mute. Switch on your mic.
Yes, sir.
Yes, please.
Thank you for invite, sister. I would like to start the webinar welcome speech with the praise of Almighty. Good morning to our respectable secretary sister, principal sister, vice principal ma'am, and honorable chief guest, and all participants from various institutions and my colleagues and my dear students. We are happy to welcome you all to this webinar on Knowledge Engineering on Artificial Intelligence. I deem it a great pleasure in organizing this webinar through the digital media. Leadership is a matter of having people look at your and gain confidence. If you are in control, they are in control. I would like to welcome Reverend Secretary Sister Margaret Inbasili for your support and encouragement. Welcome, Sister. The secret to success is good leadership. It's all about making the lives of your team members or workers better. I would like to welcome our Reverend Principal Sister Dr. V. Mary Pramila Shanti for your guidance and dedication. Welcome, Sister. A leader is one who knows the way, goes the way, and shows the way. I would like to welcome our Vice Principal, Mrs. Anthony Justina Mary, lead the webinar. Welcome, Madam. It is the supreme art of the teacher to awaken joy in creative expression and knowledge. I would like to welcome our chief guest, Mr. Dr. C.R.RENE Robin. We really thankful to him for spending his valuable time out of his busy schedule to conduct the program. Teach many innovative topics in effective teaching methodology. He has incorporated the use of computer technology. His reputation as a good teacher is recognized by many teaching honors, awards, and or nomination and invitation. Welcome, sir. Every good conversation starts with this good listening. To say that a person feels listen to me a lot more than just their ideas get heard. It is a sign of respect. It makes people feel valued. I would like to welcome all participants from various institutions. We welcome all the participants who are all have always thrust in learn new technologies. I am happy to be united as a CS family. We give assurance that we will satisfy your expectation. All of the people in my life whom I consider to be close friends, our colleagues, are good thinkers. I pride myself on respecting my colleagues. I would like to welcome my colleagues who all support in every department activity. I am profusely enjoyed to take the opportunity to introduce our chief guest of the today, Dr. C.R.RENE Robi, ME, Ph.D., Professor of Computer Science Engineering and Associate Dean from Jerusalem College of Engineering Autonomous, Chennai. Dr. C.R.RENE Robin received his ME CSE and PhD Computer Science Engineering degree from CEG Anna University, India in 2006 and 2011 respectively. He has been working in Department of Computer Science and Engineering, Jerusalem College of Engineering, Chennai since July 2006. Currently, he is working as professor and associate dean. He also worked as a programmer at the Ramanujan Computing Center, Anna University, Chennai from 2002 to January 2006. His area of interest include ontological engineering, knowledge management, e-learning, semantic web, etc. He is the recognized supervisor of Anna University to guide PhD and MS by research in the area of computer science and engineering. Four students have successfully completed their PhD program, and currently 10 research scholars are doing their research under him. He is a doctoral committee member of Anna University, Satyabhama University, and VIT University, Chennai. He is an active professional member of ACM, and ACM recognized him as ambassador. He is a lifetime member of ISTE and a member of several professional bodies. He received Mentor Award from IBM during felicitation ceremony of the Great and Mind Challenge 2011. He got the Young IT Professional Award 2012 by Computer Society of India at the regional level. He received award for teaching excellence at Indo Global Education Summit 2013. He visited the countries or Sri Lanka, Bhutan, Singapore, Malaysia, Wales and England. Every thought you produce, anything you say, any action you do it, bears your signature. Welcome, sir. I thank our management for helping us organize such a program on the occasion. Before starting the session, I request all the participants to mute your audio and video for making the program successful. I welcome you all once again for the webinar. Thank you, ma'am. Thank you, sisters, and thank you, sir.
Thank you, ma'am, for your words of welcome. A life that has gratitude with the springs of respect never forgets the blessings of the Almighty. Winner must have two things: definite goals and a burning desire to achieve them. I request our secretary sister, who has a smile in her face and a surge in her eyes, to feed our hearts with spiritual enrichment. Now comes the presidential address by our secretary sister. I welcome you, sister.
Thank you, sister. சிகரம் தொடுவதற்கு சிறகுகள் தேவை, உயரம் தொட ஊன்றுகோல் தேவை, அறிவை பெற ஆசான் தேவை. அருமையான ஆசானை நீங்கள் கண்டுபிடித்திருக்கிறீர்கள். உண்மையிலேயே கம்ப்யூட்டர் சயின்ஸ் டிபார்ட்மெண்ட்டுக்கு வாழ்த்துக்களும் பாராட்டுக்களும். அருமையாக நீங்கள் அவரை பற்றிய தெளிவான எந்தெந்த பொறுப்பில் இருக்கிறார் என்று அருமையாக சொன்னீர்கள். அவரிடமிருந்து அத்தனை கருத்துக்களையும் நீங்கள் உள்வாங்கிக் கொள்ள வேண்டும் என்று ஒவ்வொருவரையும் அன்புடன் அழைக்கிறேன். இன்றைய நாள் ஒரு இனிய நாள், வெற்றியின் நாள், கடவுள் படைத்த நாள். இந்த நாளில் ரெனி ராபின் நமது கல்லூரியின் மட்டில் நல்லெண்ணம் வைத்து இந்த நேரத்தில் நமது டிபார்ட்மெண்டின் அழைப்பை ஏற்று இங்கு பேச வந்திருப்பதை நினைத்து உண்மையிலேயே நான் பெருமையும் மகிழ்ச்சியும் அடைகிறேன். இது உண்மையிலே ஆண்டவரால் குறிக்கப்பட்ட ஒரு திட்டம் என்றே சொல்ல வேண்டும். அருமையாக அவரை பற்றி நான் ஒரு வார்த்தை, அவர் எந்த அளவிற்கு ஒரு முயற்சி எடுத்திருப்பார் என்றால், கடவுளால் ஆகாததை கூட முயற்சியால் ஆகும் என்பதை அவர் நிரூபித்து காட்டியிருக்கிறார் என்பதுதான் ஜமுனா மேம் வாசித்ததிலிருந்து நான் கண்டுபிடித்துக் கொண்டது. உண்மையிலேயே சார், உங்களை தம்பியும் தான் சொல்லணும், உங்களுக்கு உண்மையான வாழ்த்துக்களும் பாராட்டுக்களும் உங்களுடைய முயற்சிக்கு. பார்ட்டிசிபேஷனுக்கு ஒரு செய்தி நான் சொல்லணும்னு ஆசைப்படுறேன். ஒரு பையன் ஒரு ஆளு, அதாவது ஒரு இளைஞன் அவன் என்ன செய்யறான்னா, கடைக்கு போறவங்ககிட்ட எப்படியாவது நம்ம ஒரு புது செருப்பு வாங்கணும் அப்படிங்கிறதுக்காக ஒரு நூலை எடுத்து காலுடைய அளவை அளந்து அந்த நூலை பையில வச்சிருந்தான். யாராவது போனா, கடைக்கு போனா நமக்கு செருப்பு வாங்கிட்டு வரட்டும் அப்படின்னு சொல்லிட்டு அந்த பையில வச்சிருந்தான். ஆனா ஒரு வாரம் கழிச்சு அவனே போக வேண்டிய சூழல் வந்துருச்சு. அவன் கடைக்கு போயிட்டான், செருப்பு கடைக்கு. ஆனா அங்க போன பிற்பாடு பைய தேடி பாக்குறேன், அந்த நூலு காணாம். ஐயோ, நூல் இல்லையே அப்படின்னு சொல்லிட்டு அவன் சொல்றான், நான் அளவெடுத்த நூல் இல்ல, அதனால நான் போய் அந்த நூலை எடுத்துட்டு அடுத்த வாரம் நான் செருப்பு வாங்கிக்கிறேன்னு சொல்றான். அதாவது இது என்னன்னா, காலே இருக்கும்போது அந்த நூலை தேடுறான் பாருங்க. நாம எல்லாருமே நம்மிடம் இருக்கும் அறிவை முற்றிலும் நாம பயன்படுத்தாம பிறர் யாராவது உதவி செஞ்சிட மாட்டாங்களா? பிறரை நம்பியே எல்லா விஷயத்திலையும் நாம பல நேரத்துல இருக்கிறோம். அப்படி இல்லாம நமது அறிவை நம்ம நம்பி நாம் முயற்சி எடுத்தால் நிச்சயமாக நாம் வெற்றி அடையலாம் என்பதுதான் ரெனி நமக்கு சொல்லி கொடுக்கிற மிகப்பெரிய பாடம். அவர் அப்படித்தான் எடுத்திருக்கிறாரு. சார், உங்க எருசலேம்னு சொன்னதையுமே ஒரு புனித நகரம். அந்த புனித நகரத்துல இருந்து, அந்த காலேஜ்ல இருந்து நீங்க வந்திருக்கீங்க, எங்களுக்கு ரொம்ப மகிழ்ச்சியா இருக்குது. நிச்சயமாக புனித கல்லூரியில இருந்து நீங்க எங்களுக்கு செய்தி கொடுக்க வந்திருக்கிறத நினைச்சு மிக்க மகிழ்ச்சி. எங்க கல்லூரியின் சார்பாகவும் எங்க கம்ப்யூட்டர் சயின்ஸ் சார்பாகவும் உங்களை மனசார நான் வாழ்த்துறேன். உங்களுக்காக ஜெபம் பண்றேன். வாழ்த்துக்கள். இந்த முயற்சி பெரும் முயற்சி. ஜமுனா மேம நான் உண்மையிலேயே பாராட்டுறேன். அவர்களோடு இணைந்து ஷீலா, சலேத்து, இவங்க அந்த டிபார்ட்மெண்ட்ல உள்ள எல்லாருமே மிக முயற்சி எடுத்து உங்களை கண்டுபிடிச்சிருக்காங்கன்னு நினைக்கிறேன். அதனால உங்க எல்லாருக்குமே கம்ப்யூட்டர் சயின்ஸ் டிபார்ட்மெண்ட் அத்தனை பேருக்கும் ஜமுனா மேம் உங்களுக்கும் அதிகமான பாராட்டி நம்முடைய பிரின்சிபல் சிஸ்டர் இல்லாத நேரத்துல ஆண்டனி ஜஸ்டினா நமக்கு ஊன்றுகோலா இருந்து நமக்கு பல விதங்கள்ல பயன்படுறாங்க. உண்மையிலேயே உங்களையும் நான் பாராட்டுறேன். அத்தனை பேரும் இதுல பங்கு பெற்ற அத்தனை பேரும் சிறப்பாக உங்களுடைய முயற்சி, உங்களுடைய விடாமுயற்சி, தன்னம்பிக்கை இதுதான் நம்முடைய அறிவை அதிகமாக விருத்தி செய்யும். எனவே உங்கள் அனைவருக்கும் எனது மனமார்ந்த வாழ்த்துக்களையும் பாராட்டுகளையும் இந்த செமினார் ஒரு சக்சஸ்ஃபுல்லா முடியட்டும் சொல்லிட்டு நான் வேண்டிக்கிறேன். என்னுடைய ஆசி இறையாசி உங்களோடு இருக்கு. நன்றி.
Thank you,
sister, for your words of blessings and motivation. Coming together is a blessing. Keeping together is a progress. Working together is success. Take time to think the source of our strength. Hearty welcome to our Vice Principal, Mrs. St.Antony Justina Mary. She has an enormous spirit to maintain discipline. I welcome our Vice Principal to present the inaugural address. Welcome you, ma'am.
Thank you, sister. Good morning and welcome to our Honorable Reverend Sister Margaret Inbasili, the Secretary, our respected Reverend Dr. Mary Pramila Shanti, the Principal, the distinguished guest of the day, Dr.C.R.RENE Robin, the Associate Dean of Jerusalem Engineering College at Chennai. On behalf of our management and our faculty, it's a great honor and pleasure to welcome you, and also I am very happy to present this inaugural address here on the occasion of webinar on knowledge engineering in artificial intelligence. I also appreciate our CS department staff for arranging such a wonderful webinar with a skilled and eminent resource person. What is artificial intelligence? Is the ability of a computer or a robot controlled by a computer to do tasks that are usually done by humans because they require human intelligence and discernment. The world has expanded into different hemispheres with landings on the moon to Mars. As such, we live in a world of opportunities. It does not empower with multidisciplinary thinking. The applications for artificial intelligence are endless. The technology can be applied to many different sectors and industries. They are programmed to handle situations in which they may be required to problem solve without having a person intervene. These kinds of systems can be found in applications like self-driving cars or in hospital operating room. Artificial intelligence field draws upon computer science, information engineering, mathematics, psychology, linguistics, philosophy, and many other fields. Also, artificial intelligence scores 100% assured placement. As some of you may know, in less than 6 months, we have changed to our global outlook academically. We refined some of our programs and prepare to provide the best education. I cannot tell you in how many ways we will grow in the years to come, but grow we will. But doubt not, the Department of CS will be active, innovative in upgrading our academic progress. Yes, I hope this session may help you to know more about artificial intelligence in this electronic world. Participants may get a wider scope of advanced technology to access the digital citizenship. Thank you.
Thank you, ma'am, for your words of encouragement. To sharp our mind, our thoughts should be better. To catch a moment, we should refresh our eyes. To achieve something, we should have the desire and zeal. Now I invite our chief guest, Dr.C.R.RENE Robin, ME Ph.D, Assistant Professor and Associate Dean, Jerusalem College of Engineering, Chennai, to handle this session and to share his knowledge. Welcome you, sir.
Very good morning to all. It's my great privilege and honor to be here as a resource person to deliver my lecture on knowledge engineering in artificial intelligence for the institution St.Antony's College of Arts and Science for Women. I thank the Secretary Sister, Principal Sister, Vice Principal, Head of the Department of Computer Science, faculty members, and all the faculty members of the institution, Sister Seth of St. Antony's College of Arts and Science for Women. I'm more privileged to be here. I uh, I remember my school days when Secretary Sister delivered her speech. I have studied in a Catholic institution from my first standard to my 8th standard in a small village, Pudukadai, in the district Kanyakumari. So I'm very privileged to be here to serve for the community, St. Antony's College of Arts and Science for Women. So the discipline they have taught us, the dedication I have seen from them, I cannot express in my own words. I've grown in this level by the grace of God. Above all my effort, above all my thing, I always believe God, and I always think that it is purely by the grace of God I am standing here. I will not take any privilege for my effort to find my things. I give every credit to the God. With this humble beginning, let me start today's session on knowledge engineering and artificial intelligence. Like you know, I am Dr.C.R.RENE working for Jerusalem College of Engineering for the past 14 years from 2006. Currently holding the position of Associate Dean, taking care of affiliation, approval, and accreditation of the institution, and Professor of Computer Science and Engineering Department. We'll start today's section with what is engineering. You can able to see two logo. One is the logo of the leading in the University of India, having more number of institution under its umbrella, Anna University. And right hand side, you can see an emblem and logo of AICT, All India Council for Technical Education, the statutory body of Government of India controlling all the technical institution of the nations. Okay. You can see the common symbol is the wheel. Wheel invented by Mesopotamian around 3500 BC to be used in the creation of pottery. So one of the greatest invention of human being is this wheel. Engineering is a cyclic process. It has its own development life cycle process. In software engineering, we call it a software development life cycle, SDLC. And where we are living in the era of Industry 4.0, and we are slowly migrating from 4.0 to Industry 5.0. But we have to think back from where the origin. So when we look at this Industry 1.0, where it started from the invention of this wheel. I could be able to see two engineering artifact. Otherwise, I can say the second one is the artifact of the artificial intelligence invention. Be able to see? Yes. Can you able to identify the first diagram and the second diagram? Which one is the first diagram and which one is the second diagram? Name of the diagrams. If you know, you can put it in the chat. You can put it in the chat box. So it's an interactive session. You can interact with each other. You can post your comments on the chat session. A lot of people, around 200 people, are watching through the YouTube channel. Okay, you can chat and interact with me. What is the first diagram, name of the diagram, and second diagram? Let me see who is answering first. Yes. Yeah, second is Sophia, robot. It is one of the amazing artifact developed human development of an artificial. It's an example of artificial intelligence or robot. Speak like a human being and think like a human being. It has a lot of knowledge processed inside this robot, and it think, it speak, it reacts like a human being, and it has its own identity, have been recognized equally as a human being. It got its citizenship. You have to remember. What is the first diagram? This is the diagram. It is a house of the famous uh, cricket player Sachin Tendulkar. Okay, so could you able to see how beautiful the house is? Okay, so I would like to take a small virtual tour to his house. Okay, I will take you. Let us see how his house looks. Okay, we can have a small virtual view on. How amazing it is. Can you able to believe there is a house? But it's a house. You'd admire the architect, the engineering thought behind the construction of this house. The engineering thought behind this house. Okay. Okay. I'll take you to the next tour on virtual tour on the robot Sophia. Okay. You just see how the engineering
We are fascinating.
aspects.
We launch rockets to Mars, but we also do this. Yoga is made for all of us, helping you to create and to keep going. Whatever your thing, yoga for all of us.
Ad is going on. After that, you will, yeah, now it started. Yeah, let's all welcome the Sophia. This is captured when Sophia came to India. This particular function held at Kolkata. Yeah, the Sophia has arrived on stage. We are welcoming with our Indian traditional style, with the drums, with Arati. Yes, people are taking Arati to Sophia.
Together. I
Up.
heard you all have important exams
See
coming up, so
how
I
it's
wanted to give
responding.
you some advice. Study hard, but don't try to rely entirely on memorization. Think deeply about why things work the way they do. Once you start to understand that, you can solve any problem you come across on the test or later in life. Thank you so much for coming to see me. You give me so much hope for the future of humankind. I can't wait to see what you accomplish next. Thank you.
See the facial reaction, how it's reacting as human being reacts. Wow, it's an amazing one.
Thank you so much for inviting me. I absolutely love visiting Kolkata. This city is so full of art and music. There is always something fun to do here. This city is not simply the intellectual capital of India, but also the home of Mother Teresa, who taught us the importance of human ethics and values, which are very relevant to the fields of AI and robotics today. This is especially true in fields like medicine.
Yes. See, we have seen two engineering artifacts. The Sophia which you have seen is the one amazing one which got the citizenship. Okay, so we must think of how human being, the invention of human being is going on. Okay, so yeah, with a small presentation, let me continue on. Let us move on to our today's topic on knowledge engineering in artificial intelligence. Or in other words, I can say that the role of knowledge engineering in artificial, in other ways, I can say that the knowledge representation in artificial intelligence. So the predominantly we are going to discuss about knowledge. We must know from where this knowledge came. Okay, this particular pyramid is giving clear picture about it. If you look at this bottom data is nothing but facts themselves, have no meaning. Whatever I'm seeing here, I'm seeing table, chair, the almaras, the computer, flask, light, fan, the building. It's all data. Okay, information from that. The processed data is called the information, and the interpretation of the information is called knowledge, and wisdom is something related with the divine. So we started our journey with data. Relationship between the knowledge and intelligence. Knowledge engineering in artificial intelligence. Okay, training the knowledge to produce the best output of an intelligent system. In the real world, knowledge plays a vital role in intelligence as well as creating artificial intelligence. So it demonstrates the intelligent behavior in artificial agents or system. It is possible for an agent or system to act accurately on some input, whatever it may be the input. The input may be the speech, one who is interacted with the Sophia robot, and when it has the knowledge or experience about the input. And if you train them, if you have the proper knowledge, if the knowledge are accumulated in a proper way, and it is trained, if the agent is trained with the proper knowledge, definitely the output will be an intelligent, it very intelligent. So knowledge engineering is a field of artificial intelligence that creates rules to apply to data to imitate the thought process of a human being, and it looks at the structure of a task or a decision to identify how a conclusion is reached. Okay, we want a solution, better solution, find solution. So for that, we are training the agent with knowledge. A library of problem-solving methods and collateral knowledge used for. We have the problem-solving methods, so it is bundled with the problem-solving. Lot of problem-solving methods up there. We started from the algorithms and the collateral knowledge used for each can then be created and served up as problems to be diagnosed by the system. It may be any system, expert system, or the robot, or whatever it may be. The resulting software could then assist in diagnosis, troubleshooting, or solving issues either on its own or in a support role to a human. Sometimes the human intervention is required. Otherwise, on their own, the agent, the robot, the system will provide the solution to the end user. Let's see the formal definition of knowledge engineering. The formal definition was given in the year 1983 by Edwin and Pamela. The photographic I have given them. Knowledge engineering is an engineering discipline that involves integrating knowledge into computer systems in order to solve complex problem. It is not its normal issue. You would have experienced the first program you would have written as a computer science professional, adding two numbers. I tried my first program in the year 94. My first program was adding two numbers. I was wondering that why nonsense, this kind of things. Why should I waste almost the time to compute or adding two numbers? But programs are being not developed not only to add two numbers. The computer science applications are creating or changing the world. You and me are called to write programs for various applications to change the world. The knowledge engineering is an engineering discipline that involves integrating knowledge into computer systems in order to solve complex problems normally require a high level of human expertise. High level of, now software is being used to land aircraft, to launch satellites. Okay, think about the power of the programs and the computer inventions. So knowledge engineering is a process of eliciting, collecting a lot of mechanisms are there to elicitate knowledge. Once are elicited, we must structure it. We have to give proper structure, and we have to formalize. It must be machine readable, so formalize and operational. So information knowledge involved in a knowledge intensive problem domain in order to construct a program that can be performed a difficult task adequately. So let's see the knowledge engineering applications. Knowledge engineering is a technique applied by knowledge engineers. Okay, so those who are working on the knowledge base, knowledge systems will be called as knowledge engineers. And to build intelligent system, the system may be an expert system, the system may be a knowledge-based system, the system may be a knowledge-based decision support systems, the system may be an expert database system, etc. Knowledge engineering for knowledge engineering based systems. What kind of knowledge is required? Various activities of knowledge engineering specific for the development of knowledge based systems. We need to have the assessment of the problem. So not only for the knowledge based system, any problem, leave about computer problem, even our life problem, the assessment is very, 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 very important. Whenever deal with any problem, any issue in our life, we have to sit and assess, analyze it carefully before. Similarly, when you develop a knowledge-based system, the assessment of the problem is very, very important. Okay, the development of a knowledge-based system, shell or structure, then acquisition and structuring of the related information or knowledge and specific preferences, then the implementation of the structured knowledge into knowledge bases. So it's a knowledge base playing vital role. As we have the database, we have knowledge base in the knowledge engineering. And testing and validation of the inserted knowledge. Testing is as we test our house. Once the house is built, before the Graha Pravesam, we will check where everything constructed properly. So, okay, the testing and validation and integration and maintenance of the system, then revision and evaluation of the system. These are all the various phases which involved in the knowledge engineering, development of the knowledge engineering system. Okay, as you are know very familiar with the software development life cycle, where we have 7 phases, starting from requirement specification phase to till maintenance phases. Similarly, we have the specific phases in the knowledge engineering knowledge-based systems. Let's see the principles. There are different types of knowledge that requires. In the next slide, I will show the various types of knowledge. Its own approach and technique. Each has its own knowledge. Then types of expert and expertise, such that methods such be chosen approximately. Ways of representing knowledge, it differs. Okay, from one, it varies on people. So that the acquisition process can be guided by the project aims. And the structured methods increase the efficiency of the acquisition. Knowledge engineering is the process of, as I said earlier, eliciting knowledge for any purpose. It may be an expert system or artificial intelligence agent. So, as I said, we have different types of knowledge. The knowledge may be a declarative knowledge, knowledge may be structural knowledge, knowledge may be a procedural knowledge, knowledge may be a meta knowledge, knowledge may be a heuristic knowledge. So, when we handle these different types of knowledge, our approaches may vary. The creation of knowledge base may vary. Okay, we need a lot of stuff to handle the volume of data. And problems in knowledge engineering, it is complex information. It is not getting a data from a database, from a table. Okay, so it is a complex information, and knowledge is difficult to observe. Okay, we have to inference from the available information. We have to inference the knowledge from the available data. Okay, so it is a complex task. Expert and other sources differ. A lot of tools are there, a lot of mechanisms are there to represent, to develop. So multiple representation in the various textbooks, graphical representation, heuristic and skills. Okay, so it is the heterogeneous, the data, the knowledge, or the information which we get from heterogeneous places. We have to be very careful on handling the data or the information or the knowledge. The importance of proper knowledge engineering. Knowledge is valuable and often outlives a particular implementation. So we need a mechanism of managing the knowledge or knowledge management. So if you commit error, it causes a serious problem, because so as I said, the application, one of the application is landing aircraft automatically. Okay, if a small mistake, if you commit a small mistake, then we cannot compensate the calamities. Similarly, launching aircraft. So we must very careful. Okay, we have the bad presidents, past presidents. One of them is the tragedy where we lost Kalpana Chawla. Okay, so heavy damage demands on extendability and maintenance. It changes over time. So now let's see the views of knowledge engineering. We have two different views. One is traditional view. I will in the transfer view, we will talk about a traditional view. I will concentrate less on the traditional view, and we'll more focus on the modeling view, because we are living in the latest era. So it is time to discuss about the modeling view than the transfer view. Okay, the transfer view of the knowledge engineer is extracting knowledge from the human expert. If you have to sit in front of you, then olden days, if you want to develop a software, we will sit with the client, we will understand the client, what the client is expecting, and we will try to extract from the human expert. So say, for example, the best example is developing a banking application. If you want to develop a banking application, you'll interact with the bankers and we'll get the information. But whereas when you talk about the huge information where the data are available in multiple places in different formats, structured format, semi-structured format, unstructured format. So we need this transfer view. It will not help you. The old methodology will not help you. Okay, that is what we are going for. The modeling view. Mining the jewel in the expert head, they're transferring this knowledge into these are all the various steps involved in the transfer view. And the problem with the transfer view is the knowledge providers, the knowledge engineer, and the knowledge system developer should share. If they omit some of the informations, and since we are not the expert, we may omit the particular module in the system. So think about that. Assume that if the banker has not revealed there is an option of providing loan. Okay, so obviously you will miss that module in your thing. So a common view on the problem solving and a common vocabulary in order to make knowledge transfer a viable way of knowledge engineering. Okay, so the common vocabulary, common view, I can say that the best example is the library management system. We call the book, the taker, as the borrower. The name must be it's universally accepted. Borrower is universally accepted. You cannot say that no, I am not borrowing it. Okay, it is your the service, I am accepting your service. If we cannot say that's a borrow, it is borrower. Universally accepted terminology or the vocabulary commonly accepted is borrower. Okay, and the issues in conventional methods is waterfall methods. Most of the software development industries, they work on this software development process method, waterfall method, where I said no, there are 7 different types of phases of software development life cycle. We will start from the requirement specification, then we will move to analysis, then we'll move to design. Always there will conflict that whether the analysis will come first or design will come first. Okay, I just want to emphasize that analysis will come first, then we'll go for design, then we will go for the construction or the coding, then we'll go for testing, then we will go for the maintenance, implementation, then we'll go for maintenance. Okay, so it's all happening one by one, and the thing is we have to wait for the completion of the previous phase. And rapid application development method, it's a bit impossible. And the need of knowledge acquisition, here the knowledge acquisition refers to the process of gathering expert knowledge and capturing it in the form of rules and ontologies. We will talk more about ontologies and in the future slides. Knowledge acquisition has a special requirement beyond the conventional specification process used to capture most business requirement. It is not sitting in with the expert and extracting the information from the expert. I just want to say that this the olden days, gone all the days, the first generation expert systems, who Anderson consultant, and now Accenture, the name is, the Accenture company name is. So they used the shallow knowledge base, single reasoning principle, uniform representation, limited explanation. But today's application, if you say that, people are going in a very, very fast way. Overview of the trends in knowledge engineering. It's a paradigm shift from transfer view to modeling view. I said how modeling views are helping us. We will see a few more slides with respect to modeling views. The evolving of role limiting methods and generic tasks, the usage of modeling, and the influence of the ontology. So knowledge acquisition and documentation structure. It is very important, because when you develop a software, we need some procedure. Okay, anything, if you want to do something, we want some standard SOP. We always think about the SOP. If you have an SOP, we will follow the SOP. Even during this pandemic period, after pandemic period, when we reopen our institutions, we are waiting for the SOP of the government of India. So we will follow the SOP. Similarly, for any development, any process, we need standard structure. Here, the first standard structure for the knowledge development system, knowledge system, is knowledge acquisition and documentation structuring. So development of custom methodology is specifically designed to build expert systems. Okay, this knowledge acquisition and development structuring is the most popular methodology, is custom designed for expert system. Initially, it was developed by European in Europe, and slowly they migrated to United States too. And the next view is modeling frameworks for knowledge-based systems. We have the common KDAS, the advancement of the KDAS, and Mike then Protege is it's a tool which is helping us to develop the ontology or knowledge base. Common KDS principles. Knowledge engineering is not some kind of mining. It is not. It is from the domain, from the expert head, but consists of constructing different aspect methods of human knowledge. A knowledge level principle in a knowledge modeling. First, concentrate on the conceptual structure of knowledge and leave the programming details for later. The knowledge as a stable internal structure that is analyzable by distinguishing specific knowledge types and roles. So this common KDS is an advanced end of the KADS. KADS is the structure developed by Europe for the knowledge-based systems. So when you look at this diagram, knowledge engineering flow, the first module is domain expert. Then the knowledge engineer, we have domain expert and knowledge engineer. The knowledge engineer will interact with the domain expert. Then he will do something, he will do the programming, and we have at the intelligent agent side, we have inference engine, and the knowledge base, where we store all the knowledge in a structured way, in a formal way, in a mission readable way. And finally, the result will be given to the end user. So the knowledge engineering pipelines initially will represent the information in a standard format. We will see the standard formats, recommended format, universally accepted format for representing. Then we will extract the metadata and pass relationship using algorithms. The knowledge engineering process, it starts with knowledge representation. The source of, we have as I said earlier, the source of knowledge, I cannot limit with the numbers, limit by numbers. It may be available in a structured format, unstructured format, or semi-structured format. We have to, it is our responsibility to collect or elicitate it to the knowledge acquisition, and we have to represent it. Then we have to validate the knowledge, and creation of knowledge base. We will inference will be done, and proper explanation justification will be given for both knowledge base and its inference. So when you look at this block diagrams, wherever we go, we are talking about the applications of artificial intelligence. Friends, I just want to say that the artificial intelligence, the first block of artificial intelligence is knowledge engineering. It's a process to understand and represent human knowledge. Okay, nowadays, wherever we turn, we see the word data analysis, machine learning, deep learning, speech recognition, natural language processing, cognitive computing, okay, natural language generations. These are all the blocks of various blocks of artificial intelligence, where the first process is knowledge engineering. So we must know how the knowledge will be represented for an expert system, for an artificial intelligent agent. So the studying knowledge engineering would be the fundamental steps of anyone who has the aspiration to work in the field of artificial intelligence. So required knowledge for a knowledge engineer is to effectively practice knowledge engineer. And knowledge engineer require knowledge in two main: knowledge representation and knowledge modeling. How the knowledge will be represented and how we need to model. When model is nothing but mission readable way and accepted way, formal way, universally accepted way. So these are all the requirement of a knowledge engineer. If you want to become a knowledge engineer, you need to have proper understanding about knowledge representation and knowledge modeling. The study of knowledge engineering is divided in two parts. One is conceptual structure and knowledge modeling. We'll see in the later slides. So let us concentrate on the knowledge representation. Knowledge representation AI describes the representation of the knowledge. Study of how the belief, intentions, and judgments of an intelligent system can be expressed suitably for automated reasoning. One of the primary purpose of the knowledge representation includes modeling intelligent behavior for an agent. Okay, the knowledge representation includes modeling intelligent behavior of an agent. So the different kinds of knowledge that need to represent in AI is the objects, events, performance, facts, metadata, knowledge base. Okay, so we will see how these objects, events, performance, facts, everything, or metadata are modeled, represented with the help of a knowledge base for the knowledge engineering artifact. The powerful mechanism to represent knowledge base or knowledge is ontology. Okay, let us see the definition in and out of ICT. This word came from the English philosophy. It says that the study or theory of the explanation of being. So when you come to the software engineering point of view, when you look at in the software engineering and artificial point of view, a formal explicit specification of a shared conceptualization. We will see what is formal, what is explicit, what is specification, what is shared, what is conceptualization. Then only we can able to proceed further. Conceptualization is nothing but it refers to an abstract model of some phenomenon in the world which identify the relevant concepts of that phenomena. Okay, so it is an abstract view of the problem domain. It is an abstract conceptualization. Explicit means that the type of concept that constrains on the use of explicitly defined. It is defined for this particular thing. Formal refers to the fact that ontology should be mission understandable. Once it is represented with the help of a formal representation knowledge, it must be mission understandable. It must be used for processing the knowledge. Okay, and shared reflects that the knowledge is not private of some individual but accepted by the group. Okay, when you develop a knowledge base, when you develop a knowledge based system or knowledge base with the help of this ontology, you are not developing it for your own use, you are developing it for the entire universe. That is what we always said is common. Okay, so you have to share it with the community. This particular diagram, I think I have drawn this diagram in the year 2006 when I was doing 2004 when I was doing my ME in an university. So this diagram gives a very clear picture about how the knowledge, the ontology will be constructed from the bookish knowledge. Okay, so we need a book knowledge or domain knowledge. Book knowledge will be transferred to domain knowledge, and we will take the tool, universally accepted tool, ProTeach, for the construction of the ontology. What you're doing in the construction phase, we have to extract the classes, we have to extract the relationship, we have to extract the subclasses, we have to integrate the classes, subclasses, and the properties, the relationship, object properties, data properties. In addition to that, we will give the semantic representation, logic, reasoning. Then finally we'll be getting this ontology as output. This is what the way in which a knowledge base will be created. I will give a small example on the software engineering ontology. Software engineering subject I hope in one of the powerful subject. Okay, so I always say wherever I go, I insist this point. Okay, I don't know how many of you, if you really like software engineering subject, please type yes in the chat box. Do you like software engineering subject? Let me hear from you, audience. Okay, let me take 30 seconds to understand from the audience the interest level of how, what is your interest level on knowing software engineering subject. If you really like software engineering subject, please type yes in the chat box. Okay, very good, very good. I'm getting response from Raji sister, Meenakshi ma'am, and Madhu. Yes, yes, very useful session. Okay, Soumya ma'am. Okay, okay. In the meantime, you can like this video and subscribe my channel. I have lot of videos during this pandemic period. I have myself and my wife, Dr. Doreen Robin, we have given lot of webinars and lot of, especially we have trained more than 3,500 teachers from KG level to professor level to take a class with the help of virtual platforms. It means digital teachers. I can say that we have generated many digital teachers, many digital teachers. Around 3,500 faculty members we have trained. Okay, so you can, yes, you can, I have posted my YouTube channel, and you can subscribe. Those who are watching this program can subscribe my channel, so that you will get my future updates. Whenever I come online, you will get my future updates. Okay, so I have received a lot of response from the audience that you like software engineering. I too like software engineering. I'm a software engineering expert. But the pathetic situation in Indian education is, if you look at, because I'm working in engineering college, Jerusalem College of Engineering, I stress this point in many platforms, saying that we are generating software engineers without teaching them what is software engineering. Okay, the computer science students may study software engineering. My question is, what about other students? But if you ask any engineer, though they may be a civil engineer, they may be electrical engineer. If you ask them what is their aspiration, they will say that I want a white collar job in a software industry as a software engineer. Their aspiration is to become software engineer after 4 years of their study and graduation. But if you ask them what is software engineering, they are in a position now to explain what is software engineering. So wherever I go, I will insist that every engineer must study the concept of software engineering. Software engineering is a powerful subject. Every software engineer must know what is software engineering. As I started my research around in the year 2007, so this particular work motivated me a lot. This you could see the software engineering book written by Ivan Somerville, and they have converted into a set of specific engineering concepts, the project information. Finally, they have developed the ontology for software engineering. They have taken the bookish knowledge from the software engineering book, and they have developed a knowledge base. We call it as the software engineering ontology. Okay, the major people contributed for this work. This is the middle person is Ivan Somerville, the author of the software engineering book, and left hand side you can see Pom Zwankel from Australia and Elizabeth Chang. They actually they started their work. They started their work on constructing software engineering knowledge base. Okay, actually their work motivated me to do my research work. My research work on software risk management. I have taken a small portion from software engineering subject, software risk management, and explored a lot that made me to get my Ph.D. degree from Anna University. I started the work from 2007 and completed my research in the year 2011. And currently, 4 students I have guided successfully. And this weekend, I am planning to conduct the vivas of my 5th students, and a few more students are in the pipeline. And so hope you have subscribed my channel. Please subscribe my channel, and we will proceed further. Goal of an ontology, the goal of an ontology is to achieve a common and shared knowledge that can be transmitted between people and between applications. The how to model an ontology. Next question is how to model an ontology. I will give you how we develop. Now I will explain with the concept of UML. UML is nothing but Unified Modeling Language. Unified Modeling Language suggested for object-oriented systems development. Okay, so the major contributors are Booch, Rampa, and Jacobson. The model where you are very familiar with the classes, generalization relationship, and aggregation relationship. Okay, so with that understanding, now I will take you from the object-oriented thing to ontology. Whatever you are saying as classes in the object-oriented environment will be called as concepts in the ontological environment. Whatever you are seeing and in as part of the generalization relationship, here in the ontological environment, we call it as concept taxonomy. Whatever we study with respect to aggregation relationship in object-oriented environment, here we call them as part of relationship. These three terminologies, concepts are playing vital role in the concepts, hierarchical arrangements, that is nothing but the taxonomical arrangement, and how to identify the relationship, how to relate to the. So all these things are available in the object environment. If you are familiar with the UML, it's quite easy to understand the concept of ontology. So when you look at the roles of ontology in natural language applications, so ontology, natural language processing, we need ontologies, automatic extraction of knowledge from scientific text. So for example, WordNet is a powerful and the largest lexical ontologies. You could experience the WordNet. Behind what is working is the lexical ontology is working behind the WordNet. Okay, you would have experienced the WordNet, and you would have experienced the power of WordNet too. And in database and informative retrieval areas, ontology is used for improving the process of retrieval, solving the problem of heterogeneous information source that utilize different. Okay, information retrieval is a major area in computer science. Okay, what is information retrieval? Information extractions are playing vital. When I say information retrieval, I just want to say the particular work on ontology supported pattern search architecture with natural language analysis and fuzzy rules. I have given few webinars on intellectual property right, especially pattern searching and pattern filing, where I have seen one of the work of ontology, how it is helping. So here you can able to see the patent data are available here from the United States Patent and Trademark Office, European Patent Office, World and International Patent Office. Okay, so all the data are accumulated and they will be passed and transferred the data for structural clustering. Here we can get the query and the natural process analysis will be done, the tokenization, passing, POS tags, chunker, everything. The query chunks will happen here, and we will have the clusters, one cluster, so n number of clusters we have, where we'll have the textual and the semantic indexing. And we have the fuzzy logic, and finally the result will be given to the merged result will be given to the users, common users. So ontology development life cycle has its own thing. Determine the domain and scope of ontology, consider reusing existing ontology, enumerate important terms in the ontology, define the classes and the class hierarchy, define the properties of classes, define the kind of restriction on each property, identify individuals and populate classes. So, okay, so the some of the common, we will look at the ontology development life cycle. Okay, how we have the software development life cycle. Similarly, the ontology development life cycle. So one who is developing this ontology, one who is developing the knowledge base. Okay, what is ontology? Is nothing but a knowledge base. Knowledge base is required for a knowledge expert system. Okay, so this is how I can correlate with the previous slides. And determine the domain and scope of the ontology. It is very, very important. Already I said we need to know whatever action, whatever development we do, we need to know the scope of the ontology. Okay, so don't my humble request to the participants, don't hurry up for the feedback form because it goes till 12:30. Okay, the 12:30 we will share the feedback. So I'm parallelly I'm seeing the chat box also of the students. So feedback link will be shared by 12:30. Okay, it is already mentioned from 11 o'clock to 12:30 we have the session. So feedback link will be shared only at the end of the session. For your kind information, don't ask in between. Okay, so please listen the session. So here the ontology development cycle, the first step is determine the domain and scope of the ontology. So here I have given a set of questions. If you ask these questions and if you're able to identify the answer for these questions, definitely you will get the scope of the ontology. What is the domain that the ontology will cover? For what we are going to use the ontology? For what sorts of questions the knowledge in the ontology should provide answers? Who will use and maintain the ontology? If you ask this question on your own, if you're able to find out the answer, then the scope of the ontology task is over. And answers to these questions, okay, will help you to know. So, but they help limit the scope of ontology development life cycle. The step 2 is consider reusing existing ontology. Okay, so reusability is an important phenomenon in the software development. We are encouraged to reuse the components which have been developed earlier. Let it be a banking application, let it be a library management system, let it be a flight reservation system, whatever it may be. Once it is developed, we can use. Okay, so assume that you are developing a banking application for State Bank of India. Okay, so when you develop a application for Indian Bank, so what you can do is what the domains, the components which you have developed, you can take the same module and you can remodify it and you can customize it instead of starting from the scratch. Okay, so knowledge about certain domains. Similarly, in ontology, if you have because as I said earlier, once the knowledge base has been created, it must be shared to the community, and whoever wants to use, they can use it. Okay, so knowledge about certain domains may have already been engineered by domain expert. Reusing that can be reused. You can, instead of starting from the scratch, because it is a tedious job of identifying the concept, identifying the relationship, identifying the subclasses, identifying the object properties, identifying the data properties, not so easy. If somebody already they would have done, what you can do is you can make use of it, and you can use it for your export system. And step 3 is talking about enumeration, important terms in the ontology. Okay, so we have to identify the terms. So if you do a expert system for educational department, then department curriculum, lecturer and the lectures, research area, course, committee, so, lecture duties like teachers, leads project, etc. Okay, initially it is important to get a comprehensive list of terms without worrying about the overlap or whether the terms or classes or properties. And in continuation of the step 3, we have, once the comprehensive list of terms are ready, we would like to model the ontology. So we have to remove the duplicates, and now we have segregate them to the either whether it is a class, whether it is coming under properties, whether it is coming under individual. We have to segregate the terminologies, concepts, or the things which you have identified. The next step address modeling of these 3 kinds of entities in the ontology. These steps are closely intertwined. Then so we have the proven mechanisms of identifying the classes, properties, and the individuals. So you would have heard about noun phrase approach, noun phrase approach, and verb phrase approach. All the noun and noun phrases will be considered as concepts of the classes, and verb phrases will be considered as properties. Okay, use case driven approach, common class approach, class responsibilities and collaborators. You would have heard about CRC cards, where you have the classes and its responsibilities and the collaborators for accomplishing the task or the responsibilities. You have the specified format for CRC cards. If you have, you can use that mechanism to identify the classes, subclasses, and properties for while you develop your knowledge base. And the fourth step is talking about the defining the classes in the class hierarchy. Once the classes, everything is segregated, we need to go for the hierarchical arrangement. The fourth step is talking about the hierarchical arrangement. Either you can go for top-down development approach, or you can go for bottom-up development approach. So the combination of both approach can also be followed, but somehow we have to make the hierarchical arrangement. Somehow we have make the hierarchical arrangement. Okay. I'll put at 12:30. We will share the feedback. So feedback form will be shared by 12:30. Please don't disturb in between. My humble request to the participants. If you have any job, you can go and come join by 12:30. Okay. Step 5 is because I'm parallelly watching the chat. Sometimes it may discourage me seeing that feedback form. Okay, thank you. Ontology development life cycle. The next step 5 is define the properties and of classes. Classes alone won't provide enough information to answer. Along with, we need to have the properties. Properties is nothing but how the relationship, how to relate with the relationships, relate classes. Then for each property, determine which class describes. Say for example, here if you have lecture as a class, then the relevant properties are teachers leads property. A teacher will teach, at the same time the teacher will guide project. Okay, so these two are the major responsibilities of a teacher. So these responsibility, when I say teachers leads projects, it's all coming under verb. So as I said earlier, all the verb and verb phrases, all the verb and verb phrases will be come under the properties. Okay. Then all subclasses of a class inherit the properties of the class. Senior lecturer is a subclass of lecturer, so that the properties leads teachers and leads projects too. Okay, so inheritance properties, one of the important characteristics of object oriented environment is inheritance. As a son inherits the properties of the fathers, or the wealth and the properties of the father, similarly the subclass will inherits the properties and properties of the superclass. So in ontology development, day 6, to define the kind of restriction on each property, we have to provide the restriction. We have extensional restriction, value restriction, cardinality restrictions. So sometimes the number of papers a teacher can have, we can provide this information in the knowledge base. So global restriction on properties, we can enforce domain and range restriction, reflexivity, symmetry, transitivity, functionality, subproperty relationships. All those things are possible while construction, because you're not developing a database, you're developing a knowledge base where all the information must be provided in the knowledge base. And the step 7, talking about identify individuals and populate classes. Most of the remaining items from the list are individuals. Okay. So that the last item, the leaf node, will be the individual we have to identify. What is axiom? Axiom is used to impose a constraint on the value of classes or inheritance. And we have the techniques. Now we'll move to the semantic representation techniques, where since the knowledge are structured knowledge, semi-structured knowledge, and structured knowledge, we need illustration method, representation scheme, and schema, and knowledge representation, knowledge management system. So here the representation may, with the help of, you can represent your knowledge with the help of taxonomy or thesauri or ontologies. We are focusing on ontology, though we will see what is taxonomy. Taxonomy is the basic arrangement, the relationship of subclass and superclass, or the taxonomy. Here, the relationship is the relationship. All the classes are related with the single property, single relationship is a relationship, but it's not sufficient for the knowledge base, knowledge expert. So we are seeking for other representations. Here, thesaurus is another representation, vocabulary, which conceptual relationship between the terms and can be considered an extension of taxonomy with a richer semantic semantic relationship. Okay, so these taxonomy and thesaurus are helping less for the knowledge expert system. We are moving to ontology. So here I have given the basic difference between ontology and database. Ontology is a formalized vocabulary of terms often covering a specific domain and shared by a common community of users. Database is a comprehensive collection of related data organized for conventional data. It's a lot of difference we have between ontology and the database. We're able to see ontology. Name of the ontology is crime ontology. Here all the classes and relationships have been identified, and it is represented with the help of the knowledge knowledge base in the ontology in a diagrammatical representation format. Okay, you could able to see different types of different concepts which are available in the crime, and it's how these concepts are related with some of the so if you look at this crime type is one of the concepts where we have fights, clash, or brawl, then authority abuse, domestic violence, murder, theft, robbery. These are all the different types of crime. Okay, this is how we can relate, identify the concepts, relate with them each other. And when you look at this, the representational language, these are all the representational language helping us to construct the knowledge base, formal knowledge base. Okay, that is going to help after session. Could you please send your yes, sister Raji, sister, I will at the end of my slide I will give my full contact details, including my email ID and the phone number. Okay, mobile number, don't worry. Representational languages, we have W3C, World Wide Web Consortium. W3C is nothing but World Wide Web Consortium. Then HTML, Hypertext Markup Language, XML, RDF. RDF is a Resource Description Framework. RDFS is nothing but Resource Description Framework Schema. And the final one, OWL is nothing but Web Ontology Language. Web Ontology Language is one of the powerful representation language being used. I will tell more about OWL. OWL is an extension of RDF and the mission readable language for sharing and reasoning information on web. And OWL ontology representation consists of axioms. An OWL ontology representation consists of axiom and facts. Axioms are the semantic knowledge defined by building relationship between classes and properties, and the facts represents the individual assertion. Web ontology language, this is a language for processing web information. I'll tell about it. Can you able to see the G represent? What does the G represent? Please type it in the chat box. Just want to understand from you what does it the G. Yes. What does it mean, the G? Google. Very good. Very good. Dream Believer, Raji sister, Arjun, Google. Yeah. So we are very familiar. We are living with Google. If there is no Google, we are not able to live. And that kind of situation, that kind of environment era we are living. Okay, whatever you want to search, you will go first. You will go. Even something is missing at home, the first thing will come to our mind. Can we Google it? Can you Google it? Okay. So this is what our expectation. What is inside that? What is inside that G? Background picture, can you able to visualize the background picture? Background picture, yes, it's image. What does it, what is there behind the G? Owl. Okay, so owl is nothing but what owl we have seen in the previous slide? OWL. OWL is nothing but web ontology language. For your kind information, I want to tell you that Google is slowly migrating. Google is working behind the knowledge base. The knowledge which being used by Google is OWL is nothing but web ontology language. You could see the power of ontology. You could see the power of ontology. So, construction of knowledge. We need ontologists. We need people to develop knowledge bases. How it is possible? If you have proper understanding knowledge, you will create your knowledge base We need knowledge base for the entire world. We need knowledge base for the entire world. Okay, so whatever you do may be a small contribution to the community, but don't miss it out. You must, I encourage you to become a knowledge engineer and contribute for the society. So we have various elements of all the elements of namespaces, housekeeping, defining classes, defining properties restrictions, special properties, enumerators, and instances. Okay, so we have namespaces here. It looks like the RDF or the XML. You can able to see namespace is nothing but identifying the library classes from where we will take these things, and the housekeeping is something like that. And the housekeeping, we have about prior versions, version information statement, background. So when you develop your ontology, we must specify all those things, and how you will represent a class in the ontology. So can you able to see here the representation OWL column class RDF ID is equal to car is nothing but the name of the class is cars. Name of the class is car, and we have the comments where you can give the description. I have given the description of this class of cars is illustrative of a number of ontological idioms. Okay, so I have to close the comment, I have to close the class tag. Okay, this is how a small class is represented in the so where doing it, you can use this disjoint with and equivalence classes and thing nothing. If you have anything don't have any data, then you can mention this and nothing. These things are all possible. Okay, when you look at this small ontology where you have the car. Okay, so here the ontology is for the vehicle. Have vehicle two types. Okay, car is a vehicle and bike is a vehicle. Okay, when I say is it's a relationship. Okay, each vehicle has a maker, so the relationship between maker and vehicle is has a. Okay, car BMW is an instance of car, Pulsar is an instance of bike, and disjoint. Though the car and bike are coming under vehicle, these two are not same. How I will represent, how I will include it in the knowledge base with the help of disjoint. Disjoint says that though car and bike are coming in the vehicle, these two are not same. Okay, so I'm giving this particular knowledge with the help of the disjoint. This is how you are supposed to convey the message. Okay, then defining properties. This how we will define the properties, and we can properties. When I say the class name is people at India is the name of the class, and it's the union. So with the help of the union, I can go. So union consists of Muslim, Christians, Hindus, and union is I'm closing it. This how you can represent the union, and the intersections also it's possible, and the other things representations also given here has value relationship. So has value it's nothing but driven by. If I take a car driven by a person, here I can connect both the car and person. The relationship name is driven by. So this representation enumerations is available for a collection of things. January, February, December, any one of the things will be considered. So I will put it into the enumerator class. Okay, so friends, we have seen, you would have after seeing this how it's a very tedious. Don't think that's a very tedious process. Some of the tools are available for constructing knowledge base. Here the tools are listed out. If you look at the last tool, the Protige is a powerful tool where you can it is a the address is given http://protege.stanford.edu. It is developed by Stanford University, and it is available. It is a open source tool where you can download your Protege, and you can start working on it. It will not take much time. 100 MB space only it will occupy, and it's a graphical ontology development tool. Support a rich knowledge model. It's an open structure and very friendly nature. Okay, so you can experience it. The protease. I will show a small demo of how you can go protease. Okay, and I just want to emphasize the power of the tool selfie. So we are not dealing with a small amount of data. We are dealing with numerous data. Volumes of data are high. Okay, so once the ontology structure is given, we have to feed the information. Selfie is helping us. Selfie is helping us to upload bulk data. It may be lakhs, it may be crores of data. You can upload in a very easiest way. This selfie is used because knowledge engineers. When I was working for a project, I was searching what mechanism will help me to upload bulk data. So the selfie tool is helping us to upload bulk data on the ontologies, the skeleton ontology, which has been constructed in the I will show a small demo. Okay, takes a few minutes. Then in the meantime, I will also post the feedback by another 1 or 2 minutes. I will post the feedback link. Don't hurry up. Yes, can put feedback link put to them. Those who are filling, because I showed at 12:30 I will share the feedback link. I will share the feedback link. Those who are interested to know more about knowledge engineering and this tool can stay with me. I'll take 5 minutes more to yeah, don't worry. I am posting feedback link. Okay, Miss Learning Arts, Sanchu Datta sir, don't hurry up. I am sharing the feedback link for everyone. You can, okay, so I will take 5 to 10 minutes more to demonstrate the protease and the selfie. Those who are interested to know more about knowledge engineering can stay with me. Okay, thank you so much. Okay, so now you can able to see the selfie posted on feedback portal. Okay. Yeah, this is what the protease tool, where what you are going to see. Is it coming? Okay, can you able to see the protease tool? It's developed by the Stanford University, freely downloadable. You can download it. Feedback. I have shared feedback. Those who want to fill up the feedback, you can fill up. You can submit your feedback. So others, please stay with me to see the small demonstration. Okay, so I am taking one ontology, two things. One is ontology and another one is the Excel file where I have all the data to be uploaded in the yeah, here the grocery is my OWL. This is my ontology where I have the skeleton, where I have the structure. Okay, where I have the structure. Here you can able to see the grocery ontology. So if you look at the right hand side, you can able to see the metrics. Okay, how many axioms we have now. Okay, so but my plan is I'm going to upload more number of axioms, more number of things which are available in the Excel. Now it is available now. So if you look at axioms, 387 axioms are there. So this is what my ontology skeleton. This is what my ontology skeleton. I have limited information. I have 4 main things: foodstuff, grocery item, nutrition information, then store. Okay, these are all the major major concepts or the classes I have. So I have the object properties contains has nutrients and the contains foodstuff. These are all the object properties, and we don't have individual. So far we don't have individual. Our main aim is to upload the individuals. Okay, in the existing ontology. Okay, so I'm demonstrating so this is a graphical representation. Here you can able to see the root node. Here my root node is the store. So now thing is root node, and I'm moving further. I'm just showing you the foodstuff plus. So I have the basic 4 concepts: nutrition information, grocery items, food. Okay, let us explore further with foodstuff. So this is what the structure of the food in my ontology. Yes, can it be used by a beginner? Okay, first you have to experience on Proteage. Download the Proteage software from the Stanford University. I have already shown the thing. Okay, so download, then start developing your ontology skeleton. Then try to upload the file from with the help of the selfie. Then here I am opening the Excel sheet. Okay, you would have seen how I have opened it already. It's my system, so I am opening it. This is what the structure of the Excel file ready to be uploaded in the ontology. Okay, here I have the first table is grocery items, where you have the stuff grocery items. Yeah. So I'm going to this much information inside the ontology with the help of the selfie tool. Okay. Okay, create axioms for Excel. So I'm creating the axioms for Excel. So it takes time. Yeah. So could you able to see here the food ingredients, the nutrition information, foodstuff organization. Okay. Yeah. So now you could be able to see the add information. Here you are going to write the code how to extract the information from the Excel to the now I will show that the number of axioms at present is 387. We will see how it is increased, and after uploading the particular data, okay, particular column. Okay, this is what the steps required. Okay, and so in the Excel sheet, I have this particular column in A. So it is mentioned here in the grocery item A. You could be able to see. So the start column is A, and the end column is A, and the start row is 2, because first row is for the naming, and the actual data starts from, and the end row is plus. It denotes that as much as numbers. There is no restriction on the number of thing. Okay, this is how I have written the rule at A star. Okay, star is nothing but n number. There is no limit for the numbers. There is no limit for the numbers. Then I am creating the generate axioms. When I click on, now we are able to see 387. We will see after generating axioms how it is increased. 11 axioms I am including, extra 11 axioms. Add to current ontology. I am clicking add to current ontology. We are able to see now it is increased to 398. Okay, this is how we can things, and lot more informations are available. You can see the guidelines or the tutorial. You will get lot of steps. You can find it from that. Okay, so this due to the time restriction, I just want to wind up the session. I will go to the slide where you can find my contact details. I will give you the contact details, and I request all the viewers, please subscribe my channel and like this video and give your comments, so that it encourage people to know more about it. And you can also contact. We are very expert on digital teaching, and we are helping the teachers to pattern filing and research, other research issues. If you have come to last slide. So here I am giving my contact details for your information. Please have a look on it. Please note down my email ID. I'm Dr.C.R.RENE Robin, Professor, Associate Dean, Jerusalem College of Engineering. It's an autonomous institution located in the heart of Chennai. Then Rene Robin at jerusalem.eng.ac.in by mobile number. பழைய வீடியோஸ் கொஞ்சம் அது போட்டுட்டு லிங்க் போட்டுட்டு சேனல் லிங்க் போட்டாச்சு, வீடியோ லிங்க் போட்டு. Can you able to see it? Yeah, this is what my ஷேர் பண்ணிருக்கோமா? Can you able to see my contact details? Hope you can able to see my contact details. Yeah. Yeah, you will get your certificate within a week. Don't worry about it. Okay, you fill up, do the correct spelling, and your institution's name. And I'm sharing my channel name, and you can subscribe my channel. Yeah, you can subscribe my channel and like other videos also. You can see the I will give some other video links on digital teaching. We have trained more than 3,500 teachers during this pandemic period, and to helping to eradicate the digital illiteracy. One of the major issues, predominant issues, the teaching community and our developing nation India is facing is digital illiteracy. As teacher, we have to come forward. We have to train, as the secretary sister said, we need to have the zeal to learn things, to identify things. All are there. We are still searching the thread. So we have our own leg for the measurement. Don't search your thread. Okay, you are the resource. You are the resourceful person to your community. And if you learn something new and spread the information to others, that is what we are doing during this pandemic period. We are helping many teachers. More teachers have been benefited out of our webinars. A lot of things are available. Still, we are waiting to help others. So you could able to see some of my previous YouTube links, and you can subscribe my channel and stay with me. So there's a time I can hand over the session to the organizer. Can session to the organizer. From my heart, bottom of my heart, I thank the organizer. I thank the organizer, especially the HOD and my friend Dr. Anita for introducing me to the institution, to share my knowledge on knowledge engineering in artificial intelligence. Or to yes. To St.Antony's College of Arts and Science for Women. I thank you so much, Secretary Madam, Principal Madam, HOD Madam, and all other sisters and teachers for your wonderful support for delivering my knowledge to the teaching community. Thank you so much.
Thank you, sir. Thank you, sir.
Yes. And then Sheila Ma'am Malkondu. And the Salat Madam.
Robin. Really,
Yes.
we are greatly encouraged and inspired by your speech, sir. Thank you for your amazing performance. Gratitude is the attitude which gives energy to everybody. This event is successful because of the pillars of the program enhance their hardships. I welcome Mrs. Mary Sila to deliver the vote of thanks.
Good afternoon to all. First of all, I thank God Almighty for showing this blessing on us and made this session a grand success. On behalf of the management, my heartfelt thanks to our Secretary, Reverend Sister Margaret Indesili, who is behind us in all our success for arranging this session for us. Thank you, Sister. And I thank to our beloved Principal, Reverend Sister, Dr. Mary Premila Shanti, for providing the stimulating environment. Vice Principal, Professor Mrs. St.Antony Justina Mary, to inaugurate the webinar and make this day as wonderful. Thank you, ma'am. It's my immense pleasure to convey my sincere thanks to our chief guest, Dr.C.R.RENE Robin, professor and associate dean of Jerusalem College of Engineering, who presented here very patiently in between the busy work and gave the excellent information and given a valuable speech which will be an useful one for the present and future. Thank you very much, sir. We are always grateful to Mrs. M.Jamuna Rani, head of the Department of Computer Science in our college, for wonderful arrangements. Thank you, ma'am. My sincere and heartfelt gratitude to all our staff members and students on the screen. Once again, I would like to thank everybody to make this session successfully. Thank you, one and all. Thank you.
Thank you, ma'am, for your words of thanks. Thank you, sir. Thank you, one and all.
Thank you. Thank you. Thank you, Tony.